Hello everyone and welcome to the session of data science. In the last session we have covered machine learning basics. Today in this session we are going to learn about one of the machine learning algorithm, that is logistic regression. Before moving ahead, I'd like to quickly introduce myself. I'm Neha Ojha, working as a software engineer in Kepro Solutions Private Limited. Kepro is a leading provider in the field of analytics, data lake, machine learning, artificial intelligence, cloud and mobile applications development. Now let us look at the topics which we are going to cover as a part of today's session. So we'll start with the introduction of logistic regression, then we'll learn its types and application. Then we will discuss about expression and syntax used for logistic regression, and finally we'll learn about the matrices available for testing logistic regression model. So let's get started. Logistic regression is generally used where the dependent variable is binary or dichotomous, which means dependent variable can only take two possibilities such as yes, no, true, false, 0, 1, living, dead, etc. It can be called as a special case of linear regression. The only difference is here the outcome is categorical variable. This predicts the probability of occurrence of an event by fitting data into logit function. Now let's learn the different types of logistic regression. So there are mainly three types of logistic regression we have. The first one is binary logistic regression. The second one is multinomial logistic regression. And the third one is ordinal logistic regression. Binary logistic regression have only two possible outcomes, and that can be yes, no, true, false, 0, 1, etc. An example of binary logistic regression would be whether a customer will respond or ignore a marketing offer made by a telecommunication company. Second one is multinomial logistic regression. In this, outcome can be 3 or more than 3. But here there's no ordering. Like if we are making a survey to decide which kind of food is preferred more, like veg, non-veg or vegan, then multinomial logistic regression can be applied. The third one is ordinal logistic regression. As the name suggests, here the number of outcome can be 3 or more than 3, but they are ordered. An example would be a rating given to a movie from 1 to 5. So these are the types of logistic regression we have. Now let's first understand how logistic regression are used in the business world. I have listed few of its application in different sector, and the first one is marketing. Now let's suppose a marketing consultant wants to predict if a subsidiary of his company will make profit or loss depending on the characteristic of its operation. In that case, logistic regression can be used. In human resources sector, it can be used to predict absenteeism of a particular employee based on individual characteristic. In finance sector, it can be used by a bank to predict whether a customer will be a defaulter or not based on his previous transaction. And in healthcare sector, it can be used to predict whether a person is depressed or not based on the bag of words from the corpus. Let us have a look on the syntax and expression used for the logistic regression. So, the general mathematical equation for the logistic regression is in this form. Here, y is our outcome variable, that is the response variable. A, B1, B2, B3 are the coefficients, or they are the numerical constants. X1, X2 and X3 are the different independent variables that are used for predicting our outcome. Like in the case of bank, if a bank wants to predict whether an individual will be a defaulter or not, then defaulted or not defaulted will be the Y. His previous transaction will be one factor, his current income will be another factor, and the various another factors which can be used as independent variable to give this outcome. So this is the general mathematical equation we use in logistic regression. Now let's learn how we can create the regression model in R. So we use GLM function to create the regression model in R. GLM is generalized linear model function, and it's specified by giving a symbolic description of the linear predictor and description of the error. GLM takes three arguments. The first one is formula, the second one is data, and the third one is family. So formula will represent the relationship between the variables used. Data provide values to these variables, and family is the R object to specify details of the model. So there are various matrices to test the performance of logistic regression model. These matrices are not tool specific. They can be used anywhere irrespective of the tool. So I have listed few of the matrices here. The first one is archaic information criteria. The second one is null deviance and residual deviance, and the third one is confusion matrix. So this archaic information criteria is analogous to the adjusted R-square. It's a measure of fit which penalizes the model for the number of model coefficients. So basically it tests how the model is behaving when we are increasing model coefficients. So less is the deviation, better is the model. The next one is null deviance and residual deviance. Null deviance indicates the response predicted by a model with nothing but an intercept. So lower the value, better the module. Residual deviance indicates the response predicted by a model on adding independent variables. So lesser the deviation, better the module. Confusion matrix is nothing but a tabular representation of actual versus predicted value. This helps to find the accuracy of model and avoid overfitting. So these are some of the matrices which are available for testing performance of our logistic regression model. Now let us have a quick look at the topics which we have covered in today's session. So we have started with the introduction of the logistic regression, in which we have learned where we should use the logistic regression and how it is different from the linear regression. Then we have learned about the different types of logistic regression and the difference between them. Then we have learned its application in the different sector. Then we understood the syntax and expression available for the logistic regression. And finally we have learned the matrices which are available for testing the performance of our model. That's all for today's session. In our next session we will be implementing logistic regression model using R. Thank you for watching this video. You can provide your valuable feedback in the comment section. You can also write us at feedback@kpro.co.in. To learn more about new technologies, you can subscribe our YouTube channel on blockchain, cloud, data science, ETL, Datalake, DevOps, big data testing, and cloud testing. You can also follow us on YouTube, Facebook, LinkedIn, and Twitter. Thank you once again. Let's keep learning.